All right, last example. I have a couple word problems that you'll see in the notes, but we'll talk about that a little more during class. Okay. All right. So I wanted to end with one where you had to do kind of all the steps in terms of set one side equal to 0 and find the GCF. But we'll run through it a little faster than the last one, just to kind of catch the flow. All right. So first thing, set one side equal to 0. So when you're setting one side equal to 0, try to keep your squared term positive. Otherwise, you have to factor out a negative when you do that, which, hopefully that is something you did before. But anyway, so to keep it positive, that kind of keeps things simple. And so I have 31p squared on the left and 3p squared on the right. 31p squared is bigger. So if I go to the bigger one, that'll help me to stay positive. So that's what I'm going to do. So I'm going to subtract 31p squared and get that to the left. So then I want to get everything else to the left as well, so I can get the other side equal to 0, right? Okay, so these cancel out. I lined up like terms, right? So 31p squared minus 3p squared is 28p squared. 15p plus 7p is 22p. And I bring down the plus 4. And now I have it equal to 0, right? So now I want to check for GCF. So this time we do have a GCF, right? 28, 22, and 4 all have a common factor of 2. So I'm going to bring a 2 out to the front. So then I get 14p. Let me put that in blue. So then I get 14p squared plus 11p plus 2 equals 0, right? Okay, so now remember that this is pretty much irrelevant now in terms of helping me find my answer. But I'm just going to leave it there. So I don't want to forget about it, but I'm just going to ignore it, right? But I do know I'm going to end up with something like this, right? I'm going to have a p here, then I'm going to figure out what I need to put in those spots. All right, so what I'm going to do now is I'm looking inside here and I'm realizing that this is a complex quadratic, right? So after you factor out the GCF, see what you have left inside and see what kind of factoring you need to do. So here a is greater than 1, so it's a complex quadratic. So I'm going to multiply a times c. So I'm going to do 14 times 2, a times c. So 14 times 2 is 28. And now I want to find two numbers that have a product of 28 that have a sum of 11, okay? So product of 28, sum of 11. So I'm going to make a list of factor pairs, 1 and 28, 2 and 14, 3 doesn't go in, 4 and 7, 5 doesn't go in, 6 doesn't go in, 7 goes in, but now I'm back to this one, right? So that's my list. So here, these are positive, right? So that means the signs are going to be the same. And this tells me the sign of the bigger number, right? So they're both, so the bigger number is positive and the signs are the same. So that means the smaller numbers are also going to be positive. So I want to see which ones have a sum of 11. So that's these ones right here. Okay, 4 and 7. Positive 4, positive 7. Now remember, you can always double check by just multiplying these together. Positive 4, positive 7 is positive 28. And positive 4 plus 7 plus positive 7 is positive 11, right? So it works out both ways. All right, now here's the twist. Since I have a bigger than 1, I want to put that in the denominator. Okay, and then we're going to reduce. So 4 over 14 reduces to 2 over 7. So I'm going to bring that 7 to the front. So it's going to be 7p plus 2. All right. I'm just going to bring down this GCF here as well, even though, once again, that's not going to really play into the answer. And then over here, 7 over 14 reduces to 1 over 2. So I'm going to bring that 2 to the front. All right, and then the numerator is going to stay. So it's going to be 2p plus 1. Set it equal to 0. All right, and so now I'm going to have p equals -2, right? Change the sign. And then when you have a coefficient, you divide by that. So it's going to be -2/7, or p equals -1/2. So notice how it's actually the same as these, but you just change the signs, right? So that's another reason I like this method, is because you can actually go from here straight to the answer. The reason I want to show you the factored form is because sometimes you might get to a question that just says to factor. So if it just says to factor, this would be the final answer, and you'd want to keep the 2 there, right? But since we're solving, the 2 doesn't really matter, right? Because 2 cannot equal 0. And so really all that comes out is what you get out of here. And so anyway, all right, let me know if you have any questions. I know this is a long video, so I'm going to stop here. But yeah, definitely bring those questions to class. Hopefully this is a lot of review, but hopefully you found a couple tricks or remembered some things that that'll help you be even more efficient than you were before when you first learned this. Because factoring is one of those things that comes up again and again, and it's always one of the tricky things that it's a little weird at first, but hopefully it's starting to make sense and click, and you're starting to understand why we do some of the things that we're doing with factoring.